3D scans can be created in many ways, and the best choice depends on what you need to inspect. In this video, I will go through 4 methods and how you can use them. The first method is stereo imaging, which you could call the traditional way of making 3D. It's the simplest and cheapest way to create 3D, as it only requires 2 cameras that are well calibrated. Stereo imaging works by placing 2 cameras, each taking an image with a different angle to the object. Since you know how the 2 cameras are positioned in relation to each other and to the inspected object, you can triangulate from the 2 images and calculate a 3D shape. This can be done with great precision, down to less than 100 micrometers. It can be used to inspect a stationary item by taking a full image of the entire item, and also to inspect an item on a moving conveyor belt using a line scan camera. However, the downside is that it requires a lot of computing power to do the calculations. It is also slower than other methods, as you first take the images and then have to do the calculations afterwards. An alternative approach to this is to create the 3D image using structured light. By projecting light in a known pattern onto an object, you can calculate what the 3D structure looks like by seeing how the pattern is diffracted by the object. By using time-coded structured light, you apply several different patterns like stripes, giving you more data points to calculate from and thus increasing accuracy. This method can only be used on stationary objects, and you will typically need to take images from multiple angles to cover the entire object. For example, we've used this technique to create 3D shapes of airplane parts using a robotic arm to capture images from different angles in order to calculate a complete 3D structure. The third method I want to mention is laser profiling or laser triangulation. Here you project a beam of laser light onto an object and thereby reveal its contour or shape. This method is particularly effective for inspecting large parts or parts moving on a conveyor belt. A sensor detects one line at a time, and an algorithm pieces them together to create a single image. This method is both fast and highly accurate. It's just important to remember that there's a safety aspect when working with lasers. Depending on the type of laser, it can be necessary to shield it to avoid harmful reflections. Finally, I want to mention multi-view 3D reconstruction. Here we piece together a full 3D shape from multiple images from different angles. The traditional approach would be to use photogrammetry, but you can also use neural radiance fields, also called NeRFs, which require fewer images and instead rely on artificial intelligence to calculate the 3D structure based on a model of how light spreads in a room. Among other things, it's much faster than photogrammetry. So there are several ways to do quality inspections in 3D. It's just a matter of choosing the method that suits the inspection task you're faced with.